So today we're going to talk about writing a quadratic function in factored form. We already talked about writing it in vertex form. And for vertex form, remember you needed the a value and the vertex. But sometimes you might not have the vertex. For example, if you look down here at this table and you try to do the whole rainbow thing, you connect -6 to -6 and 0 to 0, there is no point in between there. You might say, oh, well, it's -6.5 right here. But you still don't know what the y-coordinate is. You don't know how far down that's going to go below -6. So we cannot use vertex form. So we need a new strategy. And our new strategy is factored form. For factored form, you need the value of a again. That's going to go here. And then you need all of the solutions, which in a quadratic function is either going to be one solution or two solutions. So you need all of the solutions, and then their solutions are going to go here and here. Remember again that this minus sign is going to mean that in the function, it's going to look like the opposite of what it actually is as a solution. So let's get started. First, we need the value of a. So from 12 to 0, that goes down 12. 0 to -6 is down 6. From -6 to -6, it doesn't change at all. And then from -6 to 0, it goes back up 6. So your second change, that's adding 6, adding 6, adding 6. So your a value is 3 because remember, it's half of the second change. Now we don't have the vertex, so we can't use vertex form, but we do have the solutions right here and right here. So I'm going to say x equals -8, x equals -5. So my function, I'm going to follow this pattern. I'm not going to get wild and crazy and put more than one equal sign or whatever else. I'm going to follow this function right here, this template. So it starts with f of x. My a is 3. After my equal sign comes a, so I'm going to put a 3 right there. Parenthesis. The x's stay x's, and then minus my first solution. But if I minus a negative, that's really adding, so I'm actually going to say +8. That minus sign makes this appear the opposite of what it actually is. And then my other solution is x minus my second solution, which is a -5, so I'm going to write a +5 right there. And that's my function in factored form. Now I'm going to do it again. So from -6 to -2, that's going up 4. Up 2 doesn't change, stays at 0. And then 0 to -2 goes down 2. So down 2. Half of -2 is -1. Sorry. So my solutions are here and here. So x equals 3, x equals 4. So my a value is -1, and then I have x minus my first solution, so -3, and then x minus my other solution, so that's -4. And that's that function to represent this table. Over here, if you look, there's not 3 points in a row. This one, and then this one's, well, I guess there are 3 points in a row. There, there, and there. So we can use this point, and this point to find the a value. So if you look, we're going to use -2, -1, and 0. Here, here, and here. Okay? And so -2 is 0. -1 is -3. And 0 is also -3. So we can use this little table here to find our a value. I just picked 3 points in a row. This one, and this one. This is in the middle of 2 points, so I'm not using that point. I'm using -2, -1, and 0. And so I can use this to find my table. So from 0 to -3, that goes down 3. And from -3 to -3, it goes nowhere, stays at 0, no change. And so then my second change, that's my first change. So my second change goes from -3 to 0, and that is +3, which means my A value is going to be 1.5. Now I could have done more to verify that my second change is the same all the way down, but I don't need to because I know this is a quadratic function. I just have to figure out what this number is. I don't need to know that it's going to be the same because I know it's quadratic. So I have my A value, half of my second change, which is 3. My solutions are at -2 and +1. Here's a solution and here's a solution. Remember, the solutions are where your function crosses the x-axis at, which means my function is my A value, x, opposite of my first solution because that minus sign means it's the opposite here. And then opposite of my second solution. That's a +1, so it's a -1 there. Okay? Now we can also do the pick 3 consecutive points to find the A value here. So it doesn't really matter which 3 you pick. Maybe I'll just pick like this one, and this one. So I'm picking at -4, -3, and -2, what those points are. So I'm going to make my table. I'll make my table right down here. -4, -3, -2. -4 is at 0. -2 is at 3. And -2 is at 1, 2, 3, 4. Okay? So here it's changing by 3. And then it's changing by 1. So my second change means that is -2, which means my A value is half of that, so -1. And notice that makes sense because I have a negative A value, and the function is opening down. My solutions are x equals -4 and x equals 0. So my function is going to be -1, x plus 4, and then 0 you can just say x. Now you don't need to say +0 because that doesn't mean anything to add the +0, so you can just keep it like nx. And then you might also see this function written like this. You have your negative from your -1, just a plain x, and then x plus 4. That's another way that you might see that function written. -1 is your A value, x is one of your solutions, and then x plus 4 represents where the other factor's solution is. So now what you're going to do is, if you turn the page, just like for Learning Target 4, there's a Desmos activity here to follow through, and that will kind of help you understand where factored form comes from, just the same way that the other one helps you understand where vertex form came from. So this will help you go to www.desmos.com/calculator and use Desmos to follow these directions and to fill out this part of your notes. So go ahead and do that right now.